Hey guys, in this video we're going to be doing the answer key for homework number 4. So we need to classify each of these polynomials as even degree, odd degree, even function, odd function. So for problem letter A, we've got two parts, A and B. So first off, because the highest power here is 6, the degree is 6, which is even. Next up, because every power here, because every power, 4 and 6, and actually the constant term, x to the 0th, 0, 4, 6, and 0 are all even numbers, so this is an even function as well. I'm actually just going to set up all of these so I don't have to change the ink color as much. So for part B here, we've got degree 3, this is odd degree. Next up, we have x to the third, maybe as their only power, but then we look at the constant term, which is really 5 times x to the 0th. Because 0 is even, we have a mix of odd and even powers, so this is neither type of function. For the next one, we've got highest power 2, which is an even degree. And then if we had to put a power for 2 times x, this would be x to the first power. So because we have a mix of even and odd numbers here, we've got neither in this case for the type of function as well. Now we're going to be doing the same thing, but using graphs. So for this one, because the end behavior is going in two opposite directions, we can tell that it has odd degree. We can't tell what specific odd number the degree is, but we do know because the end behavior is different, it's an odd degree. And now for part B, there's no symmetry here, no reflection, no rotational, so this is neither type of function. For part E, because both end behavior, both arrows are going the same way, this is even degree. And even though there is a perfect line of symmetry here, in order to be an even function, that line of symmetry has to be the y-axis, and it's not. So this is also neither type of function. Here we've got a function with end behavior going the same direction, so this has even degree. And furthermore, because it has exact perfect symmetry across the y-axis, this is also an even function. Next up, we're going to be looking at doing some polynomial division. So we're given a function f of x and a function g of x, and our goal is to state the quotient and remainder in this form. So I'm going to put that in a box, come back to that at the very end. So before we get to that, let's do our division. So you've got 2x cubed plus 7x squared minus 2x plus 8, all being divided by x plus 2. When we do this division, we should get a quotient. That's the answer to a division problem. So now, in order to find that quotient, we'll multiply by x plus 2 on both sides, canceling out the x plus 2 that we had there. This will turn our problem from a division problem into one of these weird multiplication problems, which is actually much easier to solve, where all we have to do is fill in the blank in our blue quotient. So to figure it out, we're going to do this distribution thing. So we do x times the first term has to give us 2x cubed. That means it has to be 2x squared. This gives us 2x cubed, so we can check this one off. 2 times 2x squared is 4x squared, which we wanted 7x squared. So what that means is we'll need to have a next term that when we combine it with 4x squared gives us a total of 7x squared. So x times 3x would give us 3x squared, and together those would make 7x squared, so we're good there. Next, we do 2 times 3x. This is 6x. But of course, we want negative 2x. So we need to have a next term that, when we combine, gives us negative 2x. So x times negative 8 would give us negative 8x. And together, those do make our negative 2x. Then we've got 2 times negative 8, which is negative 16. Now, looking through the parentheses, we've got our x squared, x, constant term. There's no other term that we can put here that will make things work out the way we want. So it means that we need to have one of those fixer terms, a remainder term, to correct things so we can get the 8 that we need to get. Because we already have minus 16, it means that whatever our remainder is, when we add it to negative 16, has to give us 8 total. So that looks like it's going to be plus 24. So if we do plus 24 here, that does give us our 8, and we're all set. The last part here is to actually identify what we've got. So here we've got our blue quotient. This is q of x. Here we've got, let's see, what color should I use? I'll go pink. This is our pink remainder, r of x. And then we know f of x and g of x based on the original problem. So let's write the solution to our division problem in the format that they asked us. So they want q of x, so that's going to be 2x squared minus 3x minus 8. So we've got q of x plus r of x, 24, over g of x was given to us, x plus 2. So when we divide f of x by g of x, we get this quotient, and we're left with this remainder that still needs to be divided by x plus 2. That's our final answer. Let me just label those for clarity. All right, next up, let's see. I am actually going to leave you with problem 3 to figure out. We're going to do problem 4 now. So for problem 4, we've got which of the following is equivalent to 3x cubed minus 2x squared plus 1 divided by x minus 2. So we can solve this problem in the exact same way. When we divide these, we're going to be getting a blue quotient. In order to figure out what that quotient is, let's turn our division problem into a multiplication problem. I've made a mistake. It's not x plus 2, it's x minus 2. So let me fix that. When we multiply by x minus 2 on both sides, that gives us 3x cubed minus 2x squared plus 1 equals x minus 2 times the quotient. And let me give myself some room. It looks like I will not have a quotient that big. It looks like I will need room for a remainder based on this stuff right here. So I'm leaving a little space right there. Let me use the same color coding, pink, for the remainder. All right, let's see. So to figure out what our quotient is, we'll do x times the first one. That has to give us 3x cubed, so that is 3x squared. This gives us 3x cubed as we planned, so we're good there. But when we put the 3x squared there, it also gives us negative 6x squared. Now we want negative 2x squared, so we need a next term. That when we combine will give us negative 2x squared. So it looks like we need to be adding 4x here, and I'm doing it dashed just to show that we haven't generated that yet. In order to generate this, it looks like the next term in our quotient needs to be 4x, because x times 4x would give us the plus 4x squared that we want. Negative 2 times 4x is negative 8x, and this is a weird one. We actually don't want any x if we look at the original. So we need to have a next term that completely cancels out all of these x's. So to get rid of this, we want to make plus 8x the inverse, which will enable us to completely cancel it out. So to make plus 8x here, we need x times 8. That gives us positive 8x. These cancel out as we wanted. And then next up, we need negative 2 times 8. That's negative 16. But we don't want to end up with negative 16. We want to end up with 1. So because we reached the end of our quotient, you can't go lower than the constant term. There's no negative first term in a polynomial. We need to have plus 17 as our pink remainder outside, because together that would make positive 1, which would match the original function. So you got 3x cubed, negative 2x squared, no x's, remainder fixes everything up, giving us plus 1. So now we just remain needing to find the format here. So it looks like we've got this blue quotient, 3x squared plus 4x plus 8, plus the remainder, 17, which when we put it in the form r of x, q of x plus r of x over g of x is going to leave us with 3x squared plus 4x plus 8 plus our remainder, 17, divided by x minus 2, because that was our g of x. So that is the first option. Okay, see you guys in class tomorrow. Hope this was helpful.